Good morning, gentlemen. We learned last week that when you in this video, we are going to learn how to write an equation from the balance problems we saw last week. Well, let's define balance first. As Mr. Lyons told us last week, balance is an even distribution of weight, enabling someone or something to remain upright and steady, like the bike problem we saw. Even though he's heavily loaded, because he has an even distribution of his weight, he's able to stay balanced. What's on the left-hand side is the same as what's on the right-hand side, so he is balanced in the middle. We also talked about the word equivalent. Equivalent means that something is equal in force, amount, or value. Here's the dog walker problem. Even though it looks different, these dogs are pulling with the same force as these dogs. Therefore, it is balanced or equivalent, even though both sides don't look the same. So, based on the word balance and equivalent, we changed this picture to a more simplified picture. Here is the person in the middle. That's the balance point. On the left-hand side, we have two dogs, one that's pulling 6 and one that's pulling 8. On the right-hand side, we have three dogs, one that's pulling 9, and we don't know how much the other two are pulling. But we do know that the two sides are balanced or equivalent. So with that, we can start doing some fancy mathematics. The first thing we have to understand is that two things do not have to look the same to be balanced or equivalent. We know that 3 equals 3, but 3 plus 5 can also equal the same thing as 2 plus 6, right? They both equal 8, even though they look different. So that's something we already know. Now, how can that help us solve something like this? Well, we can actually write a balance problem that looks like this as an equation if we use an equal sign where the balance happens. So instead of using a person in the middle, we can use an equal sign to show that this left-hand side equals or is equivalent to the right-hand side. How might that look? Well, it looks a little bit like this. 6 plus 8 equals, there's the person, 9 plus question mark plus question mark. So there's a mathematical equation. All I did is, instead of writing dogs and people, I just wrote the numbers, the plus signs, and the equal signs. Well, if I want to clean that up a little bit, make it a little bit more look like 7th grade math, I can simplify that 6 plus 8, right? I know what 6 plus 8 is. I don't need to write it as 6 plus 8. I could write 15, because 6 plus 8 is 14, sorry. 6 plus 8 is 14. If 6 plus 8 is 14, then I know 14 equals 9 plus blank is the same thing as 6 plus 8 equals 9 plus blank plus blank. Well, let's clean this up even more, because we don't usually see question marks in equations. We see variables. They do the same thing. They just act as a placeholder for the number we don't know. That's all a variable is, but usually it is in the form of a letter. So instead of using question marks, let's use the letter X. Well, if I do that, this becomes 14 equals 9 plus x. Notice it's the same thing as this, but instead of using question marks, I'm just going to use the letter x. Still acts as a placeholder, still don't know what that number is. And that's even the same thing as this. But again, instead of 6 plus 8, I used 14. Well, this is kind of drawn out, so what I can do is, instead of showing these two dogs as addition, x plus x, I can just say multiplication, which would be 2 times x. So this thing could be written as 6 plus 8 equals 9 plus question mark plus question mark. It could also be written as 14 equals 9 plus question mark plus question mark. That's equivalent to this, which is 14 equals 9 plus x plus x. It could also be written as this, 14 equals 9 plus 2 x's. And you can see down here, here's that original picture. There's the 6 and the 8 together as 14. Here's the person as an equal sign. Here's the 9 on the right-hand side, plus 2 dogs, 2 x's, 2 numbers we don't know. So now we have an equation that we can use to start to understand these balance problems in maybe a different way. So what I want you to do right now is go to this website. There'll be a link right here. And I want you to click log in with Google. Once you get there, choose your Google name and password, your CJ1, and click sign in. When you do that, you are going to see something that looks like this, 7th grade field trials. I want you to scroll down until you see expressions, equations, and inequalities, this little caveman picture. And then if you click on that, you'll see Unit 7.6, expressions, equations, and inequalities. I want you to click on Subunit 1. Again, that's Subunit 1, the little person holding up these shapes. And we're going to go to Lesson 2, Balanced and Unbalanced. When you get there, you'll see some numbers at the bottom. Yours will be all whited out. And you're going to click on the first one. It's going to take you to the cover page. And then we're going to click Next. And I've already submitted mine, but it's going to ask you a question. Here's 2 pictures. Kind of reminds us of the bike picture, right? Here's the person in the middle. Here's something on either side of them. Now, what do you think these diagrams represent? I said I think they represent somebody carrying something. You can say whatever you think, right? What do you notice about that picture? And then if you had to carry a heavy load, would you rather carry it like this, or would you rather carry it like this? You might even think back to a long walk to water, right? Thinking about carrying all that a really long way, carrying those water buckets a really long way. Would you rather carry it like this with this side, or would you rather carry it like this? And either answer is correct. Just pick one and then tell me which one you prefer. Then you're going to click submit. Mine's already submitted. And then once you click submit, it's going to turn this color, and then this is going to turn up as blue. That's what you want. Then you're going to go to the next slide. And you're going to look at this. So here's a similar picture we saw last time. And it says, here's a hanger diagram, because it's kind of like a hanger. It says all the pentagons weigh the same, and all the squares weigh the same. So this weighs the same as this. This weighs the same as this, weighs the same as this. So the squares all weigh whatever the same. The circles weigh something different. And based on that, what do you think must be true? Based on this, there's no numbers. What do you think must be true? What do you think could be true? That means it might be true, but there's no way to prove it. And this, what cannot possibly true? What do you know for a fact cannot be true? And this is where you have to use your noticing skills, because there's no numbers. So I wrote, one thing that must be true is the pentagon weighs more than the square, right? I know that because look at this. This is pulling down more than this. So I don't know how much they weigh, but this has to weigh more. For something that could be true, I said a square weighs the same as a circle. I don't know. There's really no way to prove it right now because they're on the same side. And I don't have numbers. One thing I said cannot possibly true is a pentagon and a square weigh the same. And I know that again from this one, right? Because this tells me a lot. This is kind of hard to tell, but this tells me a lot that these can't be the same. If they weighed the same, then they would be even like this. But this is unbalanced, therefore these do not weigh the same. I know that for a fact. Then you click submit. And again, this should turn out as a little grayed out, and then this should turn blue. And if you want to try the next one, feel free to do that. But that's where I'd like you to stop.